Good evening, one and all, and this is again a very proud moment for INAE to be able to host two very distinguished scientific managers of the country and scientists by their own right. In the morning, we had a wonderful session with Professor Ashutosh Sharma, and now we are fortunate to have Dr. Shekhar Mande with us. So it's a privilege for me to introduce the evening speaker. But before that, let me remind ourselves that it's for the first time probably in the history of INAE that we are celebrating Science Day with two very eminent scientists on the same day in two back-to-back sessions, morning and evening. And we would continue this tradition that the Calcutta chapter of INAE will host the National Science Day celebration on behalf of INAE. And it is their responsibility to identify the distinguished speaker who actually will enlighten us on this very important occasion. So now let me do my very important duty to introduce this evening's speaker, Dr. Shekhar C. Mande, who is currently the Secretary of Department Science and Industrial Research and simultaneously the Director General of Council of Scientific and Industrial Research, CSIR, which is one of the world's largest publicly funded research and development organizations, and is known for its contributions in diverse areas of science. It won't be exaggeration to say that CSIR probably is the cradle in which the science and technology of independent India gradually evolved. All the major strategic sectors and major scientific initiatives of the country essentially came from the cradle of CSIR and is somewhere or other related to CSIR. Dr. Mande is a structural and computational biologist and is one of the leading experts in DNA fingerprinting and diagnostics. He has more than 100 publications to his credit. He's a former director of the National Center for Cell Sciences, Pune, an autonomous institute of the Department of Biotechnology, Government of India, wherein he oversaw the launch of the Indian Human Microbiome Initiative in the Northeast. Dr. Mande completed his MSc from Nagpur University in 1984, obtained PhD in molecular biophysics from Indian Institute of Science, Bangalore in 1991, and then moved to University of Groningen in the Netherlands in 1991 as a senior fellow, as a postdoctoral fellow, and subsequently moved to University of Washington, Seattle, USA in 1992 for another postdoctoral stint. So then he returned to India, joined Institute of Microbial Technology, Chandigarh as a scientist, and continued until 2001. Then he joined as a staff scientist at the Center for DNA Fingerprinting and Diagnostics in Hyderabad. In 2011, Dr. Mande was appointed the director of the NCCS Pune. He also served in various advisory capacities in Government of India over a number of years. In 2005, Dr. Mande was awarded the very prestigious Santishwar Bhatnagar Prize for Science and Technology in Biological Sciences. He received many more awards, and that's no big deal at all. I mean, a scientist of his stature, he won prestigious awards like B.M. Birla Young Scientist Award in 1999, Wellcome Trust International Senior Fellow 2003 through 2008. He has been elected a fellow of all the three major science academies in the country, namely Indian National Science Academy, National Academy of Sciences, Allahabad, and the Indian Academy of Sciences, Bangalore. Incidentally, Indian Academy of Sciences, Bangalore was founded by none other than C.V. Raman, whose Nobel Prize and whose scientific exploit we are celebrating in the form of National Science Day. He's also a life member of the Indian Crystallographic Association and the Indian Science Congress Association and Indian Biophysical Society. Dr. Mande is credited with the B.C. Guha Memorial Lecture of the INSA 2017 and B.K. Bachawat Memorial Lecture of the National Academy of Sciences, India in 2017. Dr. Mande is a very renowned scientist for his research exploits in the area of protein structure and function, biology of Mycobacterium tuberculosis, structural analysis of proteins, biophysical and biochemical approaches, application of graph theory to large-scale protein interaction networks, and computational methods to analyze large-scale biological data. I may also like to add that Dr. Mande has, ever since he has taken over as DG CSIR, has taken very many initiatives for the promotion of scientific temper and culture, and more importantly, technological initiatives for translational research. We are also very happy that we have been able to create a consultative forum between CSIR and INAE. We are now holding discussions regularly, and hopefully we should soon come out with some very major initiative. So the entire Indian National Academy of Engineering is very happy, Dr. Mande, that you are spending this evening with us, and we are very keen to listen to you now. Over to you, Dr. Mande, please.
Thank you so very much, Professor Manna, for the kind words and a very extensive introduction. At times, one gets to know about oneself in these introductions. I mean, I feel very embarrassed that you have to say so many things. But thank you very much for those kind words. I do hope that there are students also in the audience today, and I'm pretty sure Calcutta is such a place, such a beautiful place. Actually, science literally rubs on you when you're walking through the streets of Calcutta, and I have seen it myself, either the college street or if you go to any of the colleges, Presidency College and all. It's amazing, I mean, how it is. And it's no wonder, therefore, that so many scientific developments have taken place in Calcutta. And in fact, the reason that we celebrate the Raman effect is also due to this city. That Sir Raman discovered Raman effect while he used to actually work in the cultivation of science in Calcutta. And then, of course, also he was the Pallet professor in the Calcutta University. He and P.C. Rai, both of them were offered professorship by Sir Ashutosh Mukherjee. And with that, actually, the Indian science scene literally flourished under their leaderships. But it is not the only one, of course. I mean, Calcutta is the center place for all the science and technology beginning of the country, whether the Boses or the Sahas or whichever you think in the early days, all of them owe their origins to Calcutta. This is such a fantastic place to be there. And in fact, once I was walking on the college street. You're able to see my slides?
Yeah.
Okay, thank you. Once I was walking on the college street, and it was very interesting. I saw large posters, and I thought the large posters must be like in any other city, Shah Rukh Khan and Salman Khan or something. It was not to be. It was actually the CERN director who was going to give a talk, and there were posters, they cult-like posters which were put up. And I thought it's rather unique for any city to have such cult around science. It's such a pleasing thing to see for all of us scientists.
Dr. Mande, there is a comment from one from the audience, and I think I was wondering, but I now see a similar sentiment that your voice is not very stable. I don't know. There seems to be. Are you using a broadband or?
I'm using my home Wi-Fi, and what I'm going to do is I'm going to switch off all of the devices which are on the Wi-Fi. Is the sound better now?
Probably the volume part is low, sir. The volume part is low.
Low volume.
Is the volume better now if I speak loudly?
Yeah. If you come closer to the microphone, maybe it is better.
Okay, I'm closer to the microphone now. So I was just appreciating the city Calcutta itself, about the awareness of science in the city. And I said that the enthusiasm about science literally rubs on anyone who visits the place. What I want to do is talk about the development of science and technology in post-independent India. And I'm afraid I have given this talk too often in recent times. And some of you might have actually heard this talk. So I would like those of you who have heard the talk earlier, please excuse me, please bear with me. Maybe some different examples actually that you see what I'm going to talk about. But the overall theme remains the same. How 75 years of journey we have performed post-independence, and how much science and technology has actually played a role in this particular journey. Before I go to that, I just want to say that human mind is naturally a very curious mind, and out of curiosity, humans always have tried to do something with the nature, which advances or rather makes our living easier. And I wanted to give an example of a very long ago example. This is something like 1 lakh to 3 lakh years old. And I actually happened to trek in the Aravallis sometimes in December. And while trekking, we came across a site. It's very close to Delhi. And the site was full of artifacts from about 1 lakh to 3 lakh years old. And what I'm showing you here is a very typical Stone Age tool from that era. Now remember, humans started forming colonies only about 15,000 years ago. And this is much before we started forming colonies. This is much before we started agriculture as a practice. This is much before we domesticated cattle. So when we were hunters gatherers, there was a need actually to make certain tools, and we had actually mastered that particular technique of making those tools. And what you see here, this site is full of such kind of tools. In fact, there are also board games which are made on the stone at this particular site. It's very fascinating. And our geographical region has always been very active in all of this. If you fast forward to about 2,500 BC, roughly the Harappan period, you in fact see that science and technology has developed much further, and people have started using science and technology even for expressing themselves. So the manifestation of human creativity was abundantly clear by something like 5,000 years ago. And some of the reminiscences that we see in a very famous statue called the Dancing Girl from the Mohenjo-daro and Harappa period, which was made of an alloy, which the people then, about 5,000 years ago, knew how to make those alloys. And in fact, the alloy, the statue was made in a lost wax technique, the technique which is used even today in many parts of the country or many parts of the world to make statues. But let us fast forward and come to 1947. 1947, actually, if we look at as a period, it's just coming out of what some of the very famous authors in India have called, including Shashi Tharoor, have called as an era of darkness. We were under the colonial occupation for roughly about 150, 200 years, and we had been robbed of all our resources. We had been robbed of all the knowledge, and we had been made to believe that all the knowledge existed only in the West, and we have been actually imparted that particular knowledge.
Yes.
And that was a very false narrative. That narrative was rather is something that I need to stop or.
No, I'm sorry, Professor Pal, kindly have yourself muted.
Okay, sorry. So, and people of Calcutta would remember the very famous famine of 1943, in which about 1 to 3 million people estimated have died in that famine. So much so that we were not even self-sufficient in making our food. And that was a challenge where the rest of the world was watching at India, how we are actually going to survive as a democracy. And remember, we had adopted democracy as the model of governance. And while the rest of the world was watching India, how we are going to survive as a republic, there came science and technology to help the society grow. And I'm going to give you some examples of this. Right? I mean, of course, in a lecture like this, it is not possible to give many different examples. I have chosen very, very few examples, some of which are very commonly known, and therefore I will not spend too much time on them. But nonetheless, I will try to explain the science and technology behind those. The first, let us actually look at the era of institution building. At the time of independence, we had only one institute that really existed, and that was CSIR. And I will tell you a little bit history of CSIR in the next couple of slides. But very soon after independence, we started Indian Council of Agricultural Research, ICMR, Department of Atomic Energy, DRDO, and so on and so forth. Simultaneously, at the time of independence, we also had only about 19 universities of higher learning. universities like Allahabad, Banaras and all, Calcutta, they existed before independence. So there was an era of also institutional building as far as the other institutes that came about. The first of the IITs, IIT Kharagpur, was founded in 1950, and the UGC itself came about in 1953. And as luck would have it, the first Director General of CSIR, Sir Shantisuru Bhatnagar, also was the first chairman of UGC in 1953. But that's a very fascinating history. And today we have proliferation of universities and IITs, and you have proliferation of the national labs of many different organizations that exist in the country. Let me come to the CSIR history part. As I said, CSIR was the first publicly funded S&T organization that came into being. And that was actually because of an editorial written in Nature by Sir Richard Gregory, who wrote in 1933 that there was a case to support science and technology in India through public funds. But British being British, they promptly forgot about this particular editorial. And the job was then left to the gentleman shown here, Sir Arcot Ramaswamy Mudliya, who was a member of the Viceroy's Executive Council, and he impressed upon the British in 1940 to start the Board of Scientific and Industrial Research, which was established in Calcutta, which eventually metamorphosed itself into Industrial Research Utilization Committee in 1941. And there actually came a council called the Council of Scientific and Industrial Research, today what we know as CSIR. It came into being in 1942, precisely 26 September 1942. And it was first established in Calcutta and later moved to Delhi. And Sir Shantisuru Bhatnagar was invited to be the first Director General of CSIR. Now, CSIR enjoyed support from public from the word go, industry and the public. And as I told you, at the time of independence, we really didn't have very highly developed industry. The Tata House existed though, and the Tatas were a strong supporter, so were strong supporters of institution building in India. And I'll show you a couple of examples even beyond it. All of you have heard the story of how IISc was founded in a conversation between J.N. Tata and Swami Vivekananda. That's how IISc came into being. But Tatas continued their charity even much beyond, and then went on founding many different institutions, including CSIR. So CSIR was one of the first organizations that they supported. And not only did they support, they also raised money by making public appeals. What I show you here is an example of making a public appeal to raise funds, what we can today call as crowdsourcing. And JRD Tata made a personal appeal through which the Calcutta's Mercantile Association, it raised rupees 44,000 in support of CSIR. And there's a letter here from JRD Tata about this particular aspect. On the latter aspect, JRD Tata also mentioned this particular letter that I'm going to quote. I am disappointed that the response from the general public has been so poor, particularly from Jamshedpur public, whose total contribution amounts to a surprisingly low figure of rupees 501. Unquote. So JRD actually supported very generously, and in fact 1/5 of the grant to start CSIR came from the Tata House, as I mentioned earlier. Not only that, sensing the need to start fundamental research institutes in the country, it was thought that there would be actually a very good fundamental institute in Mumbai, which Homi Bhabha essentially pioneered along with Shantisuru Bhatnagar, because CSIR was the only body that existed. Post-independence, all the decisions Pandit Jawaharlal Nehru would eventually bounce them off of Sir Shantisuru Bhatnagar. So he requested Bhabha to go and meet Bhatnagar, and the two together agreed that there must be an institute of fundamental research. And once again, they appealed to the Tatas that would you be willing to support it? And lo and behold, the Sir Dorabji Tata Trust decided to sponsor this particular institute by roughly 1/3 the grant. 1/3 grant came from the government of Bombay, then the Western Province, and about 1/3 came from CSIR. And over a period of time, CSIR enhanced its contribution to TIFR. And because of that, Sir Bhatnagar was also appointed as a representative of the central government to the council of TIFR. What you see here are the pictures of the foundation laying ceremony of the Tata Institute of Fundamental Research from that time. Similarly, while the Tata Institute of Fundamental Research was being founded, it was also felt that India must have a strong nuclear program. And the importance of nuclear program cannot be undermined even today. In fact, the developments of the last few days have only reaffirmed that the nuclear deterrent policy that India has adopted has been a very robust policy in terms of maintaining the security of our land. Nonetheless, the Atomic Energy Commission was to be set up, and several discussions took place in the National Physical Laboratory. This is a CSIR, one of the first CSIR laboratories to be established in Delhi. And it was felt that TFR should be the center of all large-scale research in nuclear physics in India. This committee was incidentally chaired by Shanti Swarup Bhatnagar. A committee was convened by Shanti Swarup Bhatnagar. And this committee eventually sanctioned, CSIR sanctioned, a sum of rupees 32,400 for training a group of scientists so that they could go overseas, they could come back and then start a nuclear program of India. And that's how the Indian Atomic Energy Commission would actually be set up. It was set up by the Department of Scientific Research, which was then actually CSIR, and a OM was issued by Sir Shanti Swarup Bhatnagar that there would be Department of Atomic Energy, of which Bhabha then became the first chairman of this department. You see here the letter that I was mentioning about. It is dated August 10, 1948, where Bhabha was the chairman, K.S. Krishnan was a member, and Bhatnagar was a member secretary. And then it actually said that such a commission would be set up in India. So what you see is an era of institution building in the early times. The Space Commission itself came out of the Department of Atomic Energy, and over a period of time, many different departments and universities and institutes were set up. The first wave of IITs after Kharagpur came IIT Kanpur, IIT Madras, IIT Mumbai, and IIT Delhi. So all of them were set up by 1960 or 1962. The first 5 IITs were in full operation. So we see now an era of institution building in which large number of scientific organizations were being built in the country at that time. And that has actually stood a good test of time from that particular point of time. What I want to actually tell you is not only building the institutes, but also applying the knowledge of science and technology for the benefit of society. How did we actually implement this particular knowledge that we did research in our laboratories so that the society at large benefits? There's a viewpoint that is commonly expressed around the world is that the ultimate beneficiaries of science and technology must be common people and society. And I don't think one can actually fault that particular viewpoint. What we know is that what eventually comes as a benefit of society has a strong backing of fundamental science behind it. So fundamental science is translation to generate technologies, and applications of those technologies for the larger benefit of people is one single spectrum that we all belong to. Whether we do fundamental science and advance the knowledge, frontiers of knowledge, or we convert that knowledge into technologies, or we apply those technologies for the benefit of society, all of it, we belong to the same community. And I want to give you some examples of how science and technology based solutions were applied in India from 1947. Once again, let us recall that in 1947, India's share to global economy was less than 2%. Remember, when the colonial powers arrived in India, India's share to the global economy was of the order of about 25%. So we had been robbed of almost everything. And as I said in the beginning, industry practically did not exist. We were not self-sufficient in even making our own food. And therefore, a strong science and technology and its application for the benefit of society was very much needed from the early days. And if we were to divide the entire period in our history, we could comfortably divide it in 4 or 5 different eras: that of individual excellence, that of self-reliance between 1950 and 1970. We were denied technologies as the world started realizing that we could be a global superpower, and therefore there came an era of technology denial and we making our own technologies between 1970 and 1990. And today we aspire to be a global S&T leadership. This thing. The first of the problem that we encountered while we were implementing democracy in the 1952 elections was that we had to ensure that every eligible voter in the country would get a right to vote. And how would that eligible voter come to know that that right to vote can be exercised? And for that, the problem was posed to the National Physical Laboratory in Delhi. National Physical Laboratory made this ink, what you see here on the fingers of people, used even today in all elections. And not only is used in India, now it is exported to many of the countries around the world. So this ink was eventually, the technology to make the ink was transferred to Mysore ink in 1961 and has been used in every single election in the country. Many people might dismiss this as not really very high-end science or high-end technology. But yet, please remember the enormous impact of this to implementing the democracy is absolutely phenomenal. That a simple innovation like this, we could ensure that all eligible voters could vote. I want to get another example of how simple technology can be done. India was besieged with a problem in the 1950s of very high child mortality rate. And many children were dying because mother's food was not available to them for some reason. I mean, there are always conditions in which mother may not be able to feed the child for whatever reason. The mother may not lactate, or there could be some other reasons. Mother could be in hospital, or all those. It was necessary to develop infant food in India. There were companies like Glaxo who used to make infant food, but all of it was being imported in India. The government of India then decided that they would invite international experts from New Zealand and from Scotland to try to learn how to make infant food in India. The committee, William Ridet from New Zealand, came to India, analyzed the milk that is being generated in India, and came to a conclusion that the milk that we use is predominantly buffalo milk, unlike in the Western countries, which is cow milk. And converting cow milk into infant food, things like milk powder, was easy. Buffalo milk was not easy, for the reason that the buffalo milk is very rich in fats, and because of which you can't convert it very readily into milk powder. It forms clumps. So a committee was constituted under the chairmanship of one Mr. Krishan Chand by Ministry of Commerce and Industry in 1950s, 1958, to actually see how we can start making milk powder in the country. Remember, the international experts had said that converting buffalo milk into milk powder was impossible with today's science and technology. That's what actually they had said, that today's science will not allow buffalo milk to be converted into milk powder. But our scientists did not want to lose this particular war. Verghese Kurian, who had returned to Gujarat just then from US, flew down to Mysore and met people like Subramaniam in Mysore, who was the director of CFTRI, and together they started working on this problem. And in fact, the report of the committee that you see here specifically mentions that CSIR should undertake research to convert buffalo milk into milk powder. And the scientists in CFTRI very soon recognized the problem was because of the fat content of buffalo milk. So they separated the fat from the milk by simple centrifugation. And the remaining milk can now be converted into milk powder. And those of you in the audience who are of the same age as mine would remember eating milk powder from cans like this. So our favorite childhood hobby was, when mother and father were not watching, we would sneak into the kitchen, open the can, and eat milk powder just like this. This people of my age would remember that.
Yes, yes.
And you see here, the logo of CSIR was very prominently carried on the milk can. This is the CFTRI Mysore that was carried there. And we have a lot of good memories associated with this can here, what you see here. It used to be full of milk powder. When the milk powder got over, our mothers used it to store dal. And when actually it became rusted like this, our mothers started using it for storing even soap powder. Remember, in the era when we are talking of reusing different materials, this was a classic case. We actually use and reuse the same material for different purposes. But not to forget the fact that the scientists had triumphed into making a technology of converting buffalo milk into milk powder. But would this milk powder be suitable for consumption? Human consumption, and especially children who are infants, for them to be able to consume, one has to be absolutely sure that this would not have any untoward effect on humans. And CSIR then funded a study in CMC Vellore, the Christian Medical College, in which Varghese Kurian and a CFTRI scientist went together and conducted a clinical trial to show that consumption of the milk powder was good. Not only that, it actually supplied very good proteinous food to the children. And that was phenomenal. To think of it, the technology did not exist to convert into milk powder. It may not once again be a rocket technology. It may not be something that people would talk about for ages, that we have sent man to the moon or something like that. But nonetheless, the social impact of technologies like this has been absolutely phenomenal in the growth of our country. And as we continue our journey, we want to actually emphasize the fact that not every technology need be rocket science. Not every scientific discovery win a Nobel Prize. There are many things that we can do which benefit societies enormously and have profound impact on the humanity in general. I show you here an example of similar example in Jammu and Kashmir. Now, Jammu and Kashmir, as all of you know, socio-politically, the region has generally been not very suitable for doing anything. But we undertook a couple of years ago a mission, what we actually called then as Aroma Mission, and through which we started promoting cultivation of lavender in Jammu and Kashmir. About a year ago, about a few months ago, I happened to go to Pulwama. Now, the moment you say Pulwama, people have memories of something else. Or when you say Kupwara, people actually think of something else. But trust me, this is me in Pulwama. When I went there, I saw fields of lavender being cultivated. And the lavender oil that is extracted from there now has been bringing enormous economic benefit to the people of Jammu and Kashmir. So much so that the Western media, when the reporters came to see for themselves this revolution which is unfolding right now, they termed it as the Purple Revolution. And we should be very proud that our scientists and technologists are doing things which are promoting solutions for the benefit or the upliftment of our people. Right? So the examples that I've shown are not rocket science examples. The examples I've shown are not those which will win Nobel Prizes, but yet the impact they leave on humanity is huge, is unbelievable. And with that, in the 75 years of journey, when COVID-19 came upon us, it was a newfound confidence in our S&T community. We can deal the solution. We can deal with an emergency like COVID-19. I am afraid to think that if COVID-19 had arrived upon us about 50 years ago, it would have been catastrophic. We would have to depend upon Western countries to develop vaccine and give those vaccines to us. It would have been impossible to say that India would have done so much diagnostics on our own. It would have been impossible to think that when the oxygen crisis came, that our scientists could actually develop solutions for oxygen immediately. But the confidence that we have had in the 75 years, when COVID-19 came upon us about 2 years ago, with that confidence, we have marched on extremely confidently, and we have actually come up with some very, very elegant solutions. And now we are coming to rocket science. The solutions which involve deep science and deep technologies. For example, we were challenged for diagnostics. RT-PCR was turning out to be difficult in the initial phase of COVID-19. Although we generated capability across the country, we were able to generate that capability within a very short period. But nonetheless, there was a need for doing alternate technologies. And our scientists, especially those in Delhi, in the Institute of Genomics and Integrative Biology, came up with world's first CRISPR-Cas based COVID-19 testing. And they named it Feluda. I don't have to tell you the importance of Feluda in Calcutta. The two competing technologies that were being developed in the world at that time, one of them in MIT was called Sherlock, and one of them in University of California, Berkeley was called Detector. So we were actually competing directly against the CRISPR-Cas based diagnostics, Sherlock and Detector. And our scientists were among the first ones who had come up with Feluda, which is an acronym for FN-Cas9 enzyme-linked universal detection assay. And this actually we are very proud of, that this is actually rocket science. Based on CRISPR-Cas, we have been able to generate our own technology. And there are many such technologies that we actually developed at that particular point of time, which make us very proud. The entire vaccine story, I don't need to go into it. Our scientists were actually able to make vaccine in the country. It's unbelievable 50 years ago that we had that capability of doing that. But a 75 years of journey and a capability that we have generated over a period of time through all our organizations, human resource organizations, the IITs, the universities, IISc, and so on and so forth, and the national labs together have actually shown to the world that India can do wonders. In fact, we were among the first ones in the world, even before WHO or even before the CDC Atlanta started saying that this is an airborne infection. Our scientists were among the first ones to say that airborne transmission is the major risk in the indoor settings. And therefore, one of our labs, the Central Building Research Institute, came up with ventilation guidelines for residential and office buildings. And these guidelines are available on the websites of NITI Aayog, on Ministry of Housing and Urban Affairs, the Principal Scientific Advisor to Government of India, and on CSIR's website. I would urge all of you to actually look at these guidelines and make sure that we follow these guidelines scrupulously. Not only that, as we discovered that the infection is airborne, if we treat the air before it is circulated inside a room, for example, in the air-conditioned spaces, if that air is sanitized, the probability of transmission from person to person reduces dramatically. Say places like cinema halls, say places like AC buses, say places like AC railway coaches, the probability of transmission, even if there is one or two people infected, is very high because they are closed and the ventilation is not very high. And to do that, we came up with a very simple but elegant solution that before the air enters this enclosed place, we can kill the virus by using simple UVC radiation. Now, this is not rocket science. It is known for the last 100 years that UV disinfects. And as long as the UV is concealed from human beings, it's all well. And we went and demonstrated that in the Central Hall of Lok Sabha, Central Hall of Parliament, and in Lok Sabha. And as we speak today and tomorrow, this solution is being installed also in Rajya Sabha. So what we have been able to show is that by simply disinfecting with UV, we can reduce the transmission of the virus even in indoor spaces. And it is very useful science. So I'm giving you examples of very high-end science based on very beautiful, elegant concepts. On the other hand, I'm also giving you examples which is actually not a very high-end science, but yet very profound impact science. Now, this is actually in between the two. When we started running short of oxygen, at that time, both DRDO and CSIR came together, and we decided that we are actually going to generate medical grade oxygen plants across the country. And literally within days, our people were able to come up with either the pressure swing adsorption technology or the pressure vacuum swing absorption technology both. And we were able to install these plants within a couple of months or within 3 months in many, many different places in the country. That is amazing. As soon as oxygen shortage actually came upon us, our people literally went to every district and installed plants such as this, which now today is supplying oxygen to many, many different places around the country. Now, what I have given you is example of profound scientific solutions for society. This is not to undermine the fact that behind every such solution, there is a technology, and behind every technology, there is some fundamental science. How have we done in science, fundamental science, since post-independence? And I want to give you 2 examples. There is a criticism that no Indian has ever won Nobel Prize after Sir C.V. Raman, no Indian scientist. So this criticism in part is false because we have produced scientists who are better than Nobel quality. You know, if someone says that the only peace Nobel Prizes in India, Nobel Peace Prizes, were either Mother Teresa or Kailash Satyarthi or Dalai Lama, the only 3, it would be wrong because there were people like Mahatma Gandhi who actually were above Nobel Prize. For Nobel Committee, it would have been an honor if they had actually given Nobel Prize to Gandhi and not vice versa. The same thing is true with some of our scientists. They were actually above Nobel quality. And I want to give you only two examples of this. The first example is that of G.N. Ramchandran. And I will tell you why he was above Nobel quality. When the structures of biomolecules were being discovered around the world, it was actually a very difficult task in the early days and required very elegant solutions. At that time, Linus Pauling came up with a model of what is called as alpha helix. Right, in the late 1940s or early 1950s, he came up with alpha helical model, and Linus Pauling became a legend with those 7 papers that he published in the Proceedings of National Academy of Sciences, USA. He in fact got Nobel Prize for the discovery of alpha helix. Very close on the heels of the structure elucidation of polypeptides, which alpha helix characterizes, was also the structure of DNA, which was discovered by 4 people. Popular perception is Watson and Crick, but there are 2 equally important people, Maurice Wilkins and Rosalind Franklin. 4 of them discovered the Nobel Prize was announced. Rosalind Franklin had died, and therefore the Nobel Prize was given only to 3 of them, Watson, Crick, and Wilkins. Both of them are considered to be fundamental discoveries in modern biology. Very close on the heels of discovery of alpha helix and the structure of DNA was also the structure of collagen, another very important biomolecule. The collagen structure is a triple helix, and the structure was elucidated in the remote corner of the world called University of Madras by Professor G.N. Ramchandran, shown here. Trust me, the structure of collagen made G.N. Ramchandran an international celebrity in no time, to the extent that even people became jealous of his triple helical structure. They criticized the structure very heavily, and in fact, out of the criticism that came about in the structure, G.N. Ramchandran actually answered that criticism by converting that into an opportunity and proposed something called a Ramchandran plot. Right? This is the allowed conformations of proteins in this particular region, which are colored here. Now, this discovery is absolutely fundamental. As fundamental as the discovery of bosons by S.N. Bose, the Ramchandran plot. Every biology student, when he or she opens a textbook, you will find a reference to Ramchandran plot. And very popularly, we all say that there are many Nobel laureates of biology, different biological discoveries, whose name you may try to forget, you may tend to forget, you may not know their names. But the name of G.N. Ramchandran is forever there, is immortal in the field of biology. In that particular sense, it can be comfortably said that G.N. Ramchandran was truly above Nobel Prizes. I want to give you another very outstanding science example, and because we are talking in Calcutta, I thought this example also must be given, and that of Shambhunath Day. Many people in Calcutta perhaps might not have heard of Shambhunath Day, but what he did was absolutely phenomenal. He started the entire field of exotoxins. Toxins are those molecules which are secreted by bacteria, and the clinical manifestation of many diseases is because of these toxins. For example, as all of you know, Vibrio cholerae, the bacterium which causes cholera, was actually discovered in Calcutta in the late 1800s, in the late 19th century. But the clinical manifestation of cholera is because of the cholera toxin, thanks to the work of Shambhunath Day. And he showed that not only cholera toxin, but also many other bacteria carry similar toxin molecules, which eventually manifest themselves into clinical settings. And he was nominated for Nobel Prize at least 5 or 6 times, but the Nobel Committee actually did not think so. He was the true discoverer of the field of toxins, which all of us are extremely proud of his work in those particular times. And because of discoveries like this, we actually have made some very, very good progress in terms of Human Development Index since 1947. And this is very revealing if you see. As I said, India's GDP was here at a time of independence. It has risen very fast, something like this. The life expectancy in India was 33 at the time of independence. Today is 70. Believe it or not, the life expectancy has gone more than double in the last 75 years. The mortality rate for under 5 children was 261 children per 1,000. 261 deaths per 1,000 births at the time of independence. Today, it is 34. Now, we are not very happy with the number 34 because we still want to improve this, and we want to bring it in the low tens. But yet, the progress that has happened in all of this is a testimony to the fact that we have been able to use science and technology and apply it for societal benefit in a very, very effective manner. And I've shown also you to the COVID examples. It's absolutely amazing how science and technology has done for the country. But our journey is not over. And as I said, we are at a crossroad of assuming global leadership in science and technology. We also is a nation of culture in which the material world is also connected to our soul, our mind, and we want to lead the world into that era in which not only do we understand the nature better, we also connect ourselves with that future. And some of the technological aspirations for the future, for example, are we are staring at an imminent crisis of water. The water availability in India has dropped dramatically since independence, where we were actually a water-rich country. It became a water-stressed country, and now we're actually moving towards being water-scarce country. And for this, we need solutions of science and technology to mitigate this. What I show you here is an example near Hyderabad, a village called Chotuppal, which had essentially become a semi-arid region in 2010s or something like that. Our scientists have gone there and mapped the entire subground aquifers and all those things, have shown that groundwater supply has rapidly declined because of not properly recharging the aquifers. And they actually identified places in which, if we generate artificial lakes, that the groundwater sources can also be now recharged. To the extent now, in about 5 years since then, about 7 years since then, that region is now able to grow paddy. Paddy is now being cultivated in the region, which had converted itself into an arid or a semi-arid region. We also see an evidence of people, young people, who had started migrating out of Chotuppal village and had started migrating to urban areas. But today, with the cultivation of paddy in that region, we see evidence of reverse migration. If this is not science and technology, what is science and technology? As we stare into the future, we also recognize the fact that we have to reduce our dependence on fossil fuels. And one way of reducing our dependence on fossil fuels is to use biofuels. So multiple groups in India, led by Indian Institute of Petroleum in Dehradun, have actually started generating biofuels, and they demonstrated blended biofuel with a flight of SpiceJet that flew from Dehradun to Delhi in early 2019. They demonstrated it on Indian Air Force AN-32 aircrafts on the Republic Day parade for this biofuel. Last year on 31st January, they also successfully landed a flight in Leh area. And today, they've actually shown that this has regulatory approvals from CEMILAC, making India only the second country in the world to fly biofuels flight with indigenous fuels. We are extremely proud that we actually now are only the second country in the world who can make indigenous biofuels, and we can fly our airplanes on this. We also want to embrace the future of energy with both arms. We all know that the future of energy is in clean energy, in sustainable living. And for that, hydrogen offers as one very important energy source that can be used. But hydrogen has three major problems: the generation of hydrogen, generation, storage, and utilization. There are three different issues that we must handle. And India, we have stated our ambition or aspiration as Hydrogen 212, where we would like to generate hydrogen at less than $2 a kg, store, distribute, and fuel at less than $1 a kg, and return on investment less than 2 years. With this ambition, I am pretty sure that we'll make a progress towards this in the coming few years. In fact, the first evidence of that you see here is a fuel cell bus that was demonstrated to be run on fuel cells in Pune a few months ago. There is also ambition to generate UAVs, which fly at about 20 kilometers above the surface of the Earth, with applications in telecommunications, surveillance, remote sensing, and disaster. And in another month, or rather this month, at the end of this month, we expect a prototype, which is a scaled down prototype, to be demonstrated in Hyderabad in the Wings meeting in Hyderabad. In about 2 years from now, we should expect to actually demonstrate an endurance of this UAV in nature. And if we are able to do that, that will place India once again into league of those select nations which have the technology to have high altitude platforms. And we are very proud that we have that confidence today to go over and embrace that particular future for our own development. To summarize what I have actually told you is that we have had rich tradition of science and technology through ages. We had witnessed a very affluent society until the arrival of colonial powers, and the affluence was driven strongly by science and technology. And although because of the occupation by colonial forces in our country, we missed the fruits of first industrial revolution and also that of the third industrial revolution, second and third industrial revolution. In the post-independent era, the strong emphasis that has been put on science and technology has yielded very rich dividends for our society. And as we continue our journey, our focus must be on the future of humanity and that of our planet. And when I say the future of our humanity, we look at science not only that as the material world, we look at science not only that as we want to understand nature around us, but we want to connect that with our human mind. I had a privilege of meeting His Holiness Dalai Lama about 2 years ago in Dharamshala. And His Holiness Dalai Lama told me that our culture for thousands of years has always been driven by that fact that we want human development as an integrated human development, and not only that of the material world, which is being used or exploited for our material comforts. It has to be a holistic development in which human mind also is connected to that material world. And if we are able to pull ourselves up, and if we show the same commitment as what we have done during COVID times, that is coming together of all the scientists and technologists in the country, irrespective of which organizations they work in, coming together of scientists and technologies with the industrialists, coming together of science, technology, and industry with policymakers, and coming together of all of these with society at large, I'm pretty sure that India would actually occupy its rightful place into that future global order. Let us all work toward that future. Thank you all very much.
Thank you very much, Dr. Mande.
Excellent.
As usual, it has been a really
Excellent.
extremely important and fascinating exposition of the journey of science in India before independence, since the time before independence. And it's true that you took quite a few examples, and I was listening with a lot of interest. A similar sort of I mean, one doesn't need a few of those scientists who do not need a Nobel Prize or that kind of a recognition would also be our own J.C. Bose. I mean, now it is widely recognized that he truly was the first to have demonstrated two very important things, one in botany and other in wireless communication. And
You're on dot, absolutely on dot. I mean, J.C. Bose actually rises above Nobel Prize.
Yeah. So anyway, I mean, it's for the future generation and even our own generation to actually learn very many important lessons, at the same time get inspired as what was possible in British-dominated India, perhaps set enough of a reason for us to take the whole initiative with much more vigor and make sure that we are certainly counted among the best in the world. And rewards will automatically follow. But more important is that we should be more assertive and believe in ourselves, our own capability. So thanks again. And in case there is, would anyone like to, normally in a distinguished lecture like this, we don't expect questions, but certain comments or supplements if anybody from the audience would like to make. I mean, generally, in such a lecture, Dr. Mande, I'm sure you'll agree that even when the lecture is over, we still are thinking about it. We still are trying to absorb as to, what is that? It's not about a specific subject with certain results and discussion. It's about philosophy, about journey over a period of time. And it's all the more reason why we should actually feel proud and dedicate ourselves again for the cause of science.
I actually didn't mention the many examples we can go on. For example, now that Professor Pal is here, we can actually give a 1 hour lecture on C.R. Rao himself, his work, what he did in ISI.
Right.
Or there is so much work that has actually happened all over the country. We can go on giving examples. The shortage of time, I didn't actually give those, but I mean, there are many. Everyone talks of Green Revolution, but what went behind Green Revolution was something amazing that actually brought us on a crisis that eventually affected the Green Revolution and the contributions of people like C. Subramaniam and all in all of that. So we can go on talking about it, but time is short, unfortunately.
Right. Yeah. Okay.
Our just mathematics, they don't have Nobel Prize. Otherwise, Professor C.R. Rao, lots of discoveries. So everybody knows Professor C.R. Rao.
Right. Okay. So Devtosh, can I request you to do the next?
From audience, if you have, because I know our speaker, Dr. Mande, has been engaged in several meetings and several similar talks for the last 2 days, maybe tomorrow also. So we can take one or two few comments from the audience if you have. Sir,
No, I think, Devtosh, let's not wait anymore.
Okay. So we can conclude now?
Yeah.
Okay. So it's my formal, it's my present duty for offer the formal vote of thanks, but it's truly a mesmerizing talk. Just now we enjoyed, Dr. Mande, and thank you for your kind presence and accepting our invitation to be here this evening. And like the morning session, we'll have almost equal number of participants in the day of Shivaratri, or rather in the evening of Shivaratri. So we're very happy to have this good audience.
The morning and the evening of Shivaratri.
And Dr. Mande mentioned one beautiful example of this Amul Dibba or Dabba. And we used to use in the similar way in the kitchen. And after that, mainly dal. And when it is not even good for dal, it is for detergents, right? So it reminds our childhood and our home, our mother, their practice. So thank you for your beautiful narration, beautiful description, and everyone we have enjoyed. So only thing we could not offer, not even a cup of tea. You enjoyed your own homemade coffee or tea. So next time you are so open invitation to Kolkata. We'll have lunch and dinner together. And the participants, thank you for your presence in the pandemic time. You are also engaged with so many lectures, so many talks, and particularly on behalf of Kolkata chapter, I would extend our thanks and our gratitude to Professor Mande for his constant inspiration, guidance, and encouragement. And INAE headquarters, INAE office, they have extended their fullest support for these 2 sessions today. So with these words, we can conclude this session today with your permission.
Thank you very much. Thank you very much,
Thank
Dr.
you.
Mande. Namaskar. Okay. So we come to the close of the session.
Thank you.
Thank you.